Hello students, I'm sure that my students are doing great, they are fit and fine. As I have promised, again I have come back with a new series, that is reaction mechanism series. And to start the series, I'll be taking up questions from free radical substitution reactions. So usually, which organic compounds do you think students will undergo free radical substitution reactions? Please do comment in the chat box, right? Chalo, let's start the session, guys. So here we go. A methyl cyclohexane has been given to you and is asking you to calculate the number of monochlorinated products excluding stereoisomers. Then the second question is calculate the number of monochlorinated products. Then total number of resolvable products, total number of enantiomeric pairs, total number of fractions obtained during fractional distillation. In a single question you have multiple questions, students, total 5 questions. And in free radical substitution reaction, this is a very important part. So let's start. So first let us carry out the reaction. You have a methyl cyclohexane and you have to go for chlorination. During chlorination, which are the parts where you expect the chlorine can be attached? To start with, on this carbon, then followed by this, then followed by this, then followed by this. Either you attach this side or this side, it will be the same. Either you attach here or here, it will be the same. So let us try to write down the products. So this is the first one. This is the second one. This is the third one. This is the fourth one. And finally, this is the fifth one. So how many number of monochlorinated products we got? 1, 2, 3, 4, 5. We didn't include any of the stereoisomers. So we have got 5 different monochlorinated products. Second one is asking you to calculate the number of monochlorinated products. So when he has given monochlorinated products and he hasn't mentioned anything regarding stereoisomers, that means we have to include stereoisomers also. In the first compound, do we have any chiral center? No, there is no chiral center. So you will have only one from this. Second one, do you have any chiral center? No. Again, we'll have one from this. Third one, you have a chiral center? Yes. How many? 1? No. It's 2 chiral centers. This is 1 and this is 1. So when you have 2 chiral center and there is no symmetry, then the total number of optical isomers will be 4. Then in the fourth one, again, you have 2 chiral centers. Again, there is no symmetry in this. When there is no symmetry, again you will have total 4. In the last one, do you have any chiral center? No, we don't have any chiral center. Stereomers. Stereoisomerism means what? Stereoisomerism can be both geometrical and optical. Can we have GI in the last one? Yes, my dear students, we can have GI. If you ignore GI and you just check the optical activity and if you consider 1, then definitely this is a mistake. This is where the students do make a mistake. So whenever they think about stereoisomerism, always the back of mind, they always think about only optical isomerism, which you also need to take care of GI. Anyway, the first 4 already, in the third and the fourth, in the optical isomerism, the GI is already a part of it. So that should not be any problem for us. So in this, GI is possible. So accordingly, you will have 2. So total how many we have? 8, 10, 11, 12. So for the second one, we have answer 12. Total number of resolvable products. What do you mean by resolvable products? The one which are optically active. The one which are optically active. So when you're asking resolvable product, you need to take both the enantiomers. I mean, what I mean to say, both D and L, both dextro and levo. So we have 4 here and 4 here. So total resolvable products will be 8. So when you have 8, it gives you how many enantiomeric pairs? 4. Yes. So total number of enantiomeric pairs is 4. And the last part of the question is asking you to calculate the number of fractions obtained during fractional distillation. Yes. For the first one, you will have only one fraction. For the second one, again you will have one fraction. For the third one with 2 chiral centers, you will have 2 fractions. Again for the fourth one, you will have 2 fractions. Again for the last one, you will have 1 fraction. So total how many? 1, 2, 4, 6, and another one is diastereomer, geometrical isomer, guys. So when you have geometrical isomer, they are diastereomeric relationship. So you will have 1 or 2. You will have 2 in total for this. Because for cis, you will have 1 fraction, and for trans, you will have another fraction. So we have 1, 2, and 2 here. So 4, another 2 here, 6, and another 2 here. So total you will have 8. Is that clear? Come on, guys. Let's move to the next question. This is another interesting question where you need to calculate the total number of possible products. Again, you have to give the total number of possible products for this. So for attending this question, definitely you need to have a fair idea regarding the reaction mechanism. So NBS, what is NBS? N-bromosuccinamide. What is the use of N-bromosuccinamide? It is used for allylic bromination. This carbon-carbon double bond is vinylic. Next to the vinylic carbon, we have allylic. So the allyl radical can be stabilized. That is the reason why the driving force for NBS to have allylic substitution. So this is here and this is here. So you have in total 2 allyl radicals. One is a tertiary allyl radical, the other one is secondary allyl radical. So chalo students, let's write the reaction with the mechanism. So radical at the tertiary carbon, so it will involve in resonance. So once it involves in resonance, it will have homolytic fission. So this is a new radical formed, right? So this is with respect to tertiary radical. So here, when Br radical attacks, you will get one product here. With this, you will get one more product. This is with tertiary radical. Again, we have to check with secondary radical. So with secondary radical, one product you will get. Again, you have to check with resonance, odd electron pi conjugation. So you will have a double bond here. Again, you will get a radical here. Then the Br radical will attack. So here also Br radical attacks. So total, how many products you got? This is 1, this is 2, this is 3, and that is 4. Is asking you total number of products. Definitely we also need to check the stereoisomers for this. Okay. So if I take this is A, this is B. A and B are usually the major products because they are formed from the tertiary radical. And this is C and this is D. Come on, let's check now. So do you have any chiral center? Yes, we have a chiral center here. So here you will get 2. Here do you have a chiral center? Yes, we have one chiral center. So here you will get 2. Then here do you have any chiral center? Yes, we have 2 chiral centers. So we will get 4. Here do you have any chiral center? Yes, 2 chiral centers. Again you will get 4. So 4 and 4, 8 plus 2, 10 plus 2, 12. So total number of products possible are 12. This is a very common question, students, very common question which you expect in the JEE Mains examination as well as JEE Advance, where students do miss at least 1 or 2. So for this, your concept of isomerism should be very, very clear. Then only you can attempt such stereochemistry driven based questions. Right? Chalo, let's move to the third one. 2 bromo, 1, 2, here we have first carbon, second, third, fourth. So we have 2 bromo butane and we have to go for bromination, and is asking you to calculate the number of dihalo products including stereoisomers. Again we have question based on stereoisomerism. Yes, for free radical substitution, definitely stereoisomerism is a part of it. So let's write down the structures first. You can have bromine here at this carbon, at the first carbon. So others we will put as it is, CH2, CH3. This is the first one. Second, we can expect replacing this hydrogen. Bromine, bromine. So this CH3 will be as it is, and this will be CH2, CH3. Now coming to the third one. On the third carbon we will try to put, others will remain as it is. CHBr, CH3. Next, in the fourth one, CH3, H, Br, CH2, CH2Br. Now let's check. In the first one, if I take this is A, this is B, this is C, this is D. First carbon, second carbon, third carbon, fourth carbon. In the structure A, do we have any chiral center? Yes, you have CH2Br, hydrogen, bromine and ethyl. So from this how many you will get 2? In the second one, do you have any chiral center? No, right? Bromine, bromine, there is no chiral center, you will get only 1. Third one, do you have any chiral center? Yes, this is a chiral center. Again, this is a chiral center, right? And there is no symmetry. There is no symmetry here. So you will have 2 chiral centers, so it will have 4. Here you have how many chiral centers? Only 1. So 1 chiral center, so 2 products. So total how many? 2 plus 1, 3, 3 plus 4, 7, 7 plus 2, 9. So total 9 products are possible. Is that clear? I hope students you are enjoying the session. These are very, very important, very, very important. As I told you, the concepts of optical isomerism must be crystal clear. Then only you'll be able to understand these questions. Chalo, let's move to the next one. Major product obtained in the following reaction. Guys, whenever you look at NBS, students do jump at the conclusion that yes, this is allylic bromination. No, NBS can also be used for electrophilic addition. So this is something different. N-bromosuccinamide. So when I draw the structure of N-bromosuccinamide, you will see C double bond O, C double bond O, CH2, CH2, C double bond O, N with bromine attached. Okay. In presence of sunlight, it will undergo homolytic fission. In a way, polar protic solvent, can you expect to have a homolytic fission? No, right? Polar protic solvent always drives for heterolytic fission. So the bond between nitrogen and bromine is shifted towards bromine. Sorry, it is shifted towards nitrogen because nitrogen is more electronegative. So nitrogen will get a negative charge, bromine will get a positive charge. When bromine gets a positive charge, bromine is a very bulky electrophile. It binds to the carbon-carbon double bond, forming a cyclic brominium ion, a highly unstable cyclic bromonium ion. Now, the water molecule, which is a nucleophile, will attack in such a position that it favors Marconic of addition. Marconic of addition is always driven by carbocation stability. So here the secondary carbocation is this. When oxygen attacks, it gets a positive charge. Immediately H plus ion will be released. So what will you get? OH. So this bond will break. This partial positive charge will be reduced. Bromine and OH group will be attached. So OH and bromine, that is option C. But usually students, what do? They don't care of this solvent water and simply they will go for allylic substitution and they go for option A, which is quite incorrect. Is that clear? It's a good one, right? Chalo, let's move to the next one. This is the last question for this series, for this reaction mechanism series for free radical substitution. Again, I'll come up with the one more set of questions for free radical substitution reaction, guys. Don't worry. Come on. Major product with respect to for this reaction. He has given orthoxylene. If two methyl groups attach to the benzene ring at 1, 2 positions, then it is ortho position, and two methyl groups in the benzene ring is called as xylene. NBS, you need to take it as two equivalents. So when you're taking two equivalents, first it attaches itself to the benzylic position. CH2Br will be formed. In another mole, it will form CH2Br again. Now NaOH is one equivalent. Now both are of the same. No difference, the environment is same. So one of them will be replacing with OH group. This is which kind of reaction? Nucleophilic substitution reaction. Then what happens? You have sodium. Sodium is an active metal. It actively displaces hydrogen. So the bond between oxygen and hydrogen is shifted towards oxygen, so that the sodium gives electron to the H plus ion. So what does it form? You will have CH2, O minus, and this CH2Br. Now this will be a kind of intramolecular SN2 reaction, internal attack, where O minus attacks on this carbon and the bromine will go out. CH2, O, here you have CH2. Is that clear? So this is how many membered ring? You can check. This is 1, this is 2, this is 3, this is 4, this is 5. 5-membered ring and 6-membered ring, they are always driven with the intramolecular SN2 reactions. I hope students, you have enjoyed this session. Please go through the earlier recordings of general organic chemistry. If you have any queries, please do let me know. There was some audio issue, students, for the last recording. I'm extremely sorry for that. In future, the same questions, if it's required from your end, I will definitely again re-record it. And one more thing, as I have told you, students, please join the Telegram channel for regular updates so that you can get most of the material which I usually take up in my offline centers. And also I'll be giving some practice exercises to my students. So that will be definitely helpful for you also. So finally, please don't forget to like, share and subscribe your SURYA'S World of Chemistry, your favorite YouTube channel, students. That's all, students, for this session. Please take care. Bye-bye.